Hi there. So for chemistry today, I am going to do a few things. I'm going to go over the answers from yesterday, and then I will get us started in concept four, which is going to kind of just piggyback off of what we have been doing. And then I will give you some work time to work on basically finishing up your packet here because we're pretty much done. So I'll walk you through what we're going to be doing. First thing is I want to take a look at yesterday's answers. Now, some of you already looked at these from yesterday, but if you have not had a chance to, take a look up here to make sure that they match. So you'll notice 4 and 5. I left them in scientific notation, but you could have taken them out of scientific notation um, and wrote them, as regular notation. That would have been fine. And none of these answers are in scientific notation. They could be, but they don't have to be. It doesn't say that it does. So that's 1 through 5. Scroll down here and we'll look at the back page, so 6 through 10. So 8 and 9 we did together in class. This is supposed to be a 10 here. The only thing that it doesn't show is kind of like your sort of your division at the end before you get your final answer. I find that does help to do that. But you can see 8 and 9 both take the longer way, the actual two-step method. So going from micrograms to grams, then back to milligrams. I showed you yesterday how you can combine like the 1,000 milligrams over the 1 million micrograms. You could also have done that here for 9, 1,000 millimeters over 10 decimeters, and you'd still end up at the same answer. So either way you want to do it, but I just want kids to get confused thinking that you can put them over each other all the time. It only works if you're both in both the bottom of the chart or the top. Now 10 was going from, one extreme here, megaliters. It wants us to get to from milliliters. So 4.567 times 10 to the fourth milliliters. So that would have been 45,670 milliliters to start with if you did that instead of the scientific notation. And then you're going to divide that by 1,000 times a million. And what you should get is a number like this. Either you'll have it in scientific notation, possibly 4.567 times 10 to the negative fifth, or I wrote it out for you to 0.00004567. And that's megaliters with a capital M is your final answer. So make sure you don't see the difference between milliliters and megaliters. All right. So looking at the next topic in our notes, we're going to go to page 25. And this will be pretty quick because we're basically just going to expand on this a little bit. And instead of doing, 1 or 2 step problems, it'll be a little bit more. But usually we're going to, most of the time we'll use units that we're a little bit more comfortable with. So for this, let me maneuver my screen around here a little bit. So I'm on the top of page 25, concept 4. So after today, should be able to use the previous objectives to carry out dimensional analysis. Remember, I abbreviate that DA sometimes. Calculations with more than 2 steps. So you thought 2 steps is bad. We're going to do a few more now. and round answers to your appropriate number of significant figures. We're still going to use the rule of using however many are given in the problem. So here's our example. On the top it says, how many seconds are in 1.50 weeks? Now it's an odd way to write it, but I'm saying in 1.50 weeks exactly, right? That zero tells me precision. So how many seconds are in a week and a half? So think about this. I mean, there are like a few ways that you could probably figure this out, like in your head. I mean, most of us understand time and stuff like that, so we can probably figure it out. But I'm going to show you how to do this with dimensional analysis. Okay. So our rule doesn't really change. I start off by writing down what I'm given, my known and my unknown. My known is 1.50 weeks. My unknown is seconds. Again, optional if you want to write that. I essentially need to go from week to what's my next lowest unit that I can go to. Well, I can go to days. I know how many days are in a week. From days, I can't go to seconds. I can go to hours, though. And then from hours to minutes, minutes to seconds. So this is where I said that writing a plan of attack is very helpful when you have multiple steps such as these. So that's your plan of attack. The conversions will come up on here. You don't have to write these down because we're just going to put them into our, when we work it out here. But as you know, 1 week is 7 days, 1 day is 24 hours, 1 hour is 60 minutes, and 1 minute is 60 seconds. All right. So I start off my analysis the same, 1.50 weeks over 1 or over x times, and then I'm going to give myself a little space. So my rules still apply. I want to have the unit that I want to cancel out here at the bottom. So that's weeks. So I'm going to put a week down there. And I need to go to days. So I'm going to put my days up there. And according, I know that there are 7 days in a week. So my weeks and weeks cancel. And now I basically start over each time. So now I only have days. I have days on the top, which means I need days on the bottom. And days or day will cancel. They don't have to be exactly the same singular or plural. So then I have to go, okay, how many days and hours? How many hours in a day? 24. So then days and days will cancel. Same thing. Set up another one. Hours on the bottom, minutes on the top, hours cancel. And minutes on the bottom. Finally, seconds on the top, minutes cancel. So essentially what I need to do is multiply all my top numbers going across. And then if I do have any numbers that aren't 1, I have to divide by them on the bottom. But all I have is 1. So whatever I have on the top will be what I end up with. So I have to take 1.5 times 7 times 24 times 60 times 60. And you get 907,000 seconds. Now, you also could write that in scientific notation. Remember my sig figs. So I needed 3 significant figures here for my answer. All right, so when I round that to 3 significant figures, 907, those 3 are all significant, but these 3 are not. So this one would be right. I can also write it in scientific notation. My pen's off there, but so my decimal technically is right here, and I would go 1, 2, 3, 4, 5. So that would be 9.05 times 10 to the positive 5. All right, so these aren't too bad because they're usually used with units that we're more familiar with. So we don't have to worry about, milli, centi, any of those. We might still use them, but you don't have to worry about them quite as much. So two new conversion factors you must know we're going to put in this box on page 25. 1 inch is equal to 2.54 centimeters. And 1 mile is equal to 5,280 feet. Just hang on a minute here. Remember that I can write them like that, but then when I use them, it can always look like this. 1 inch over 2.54 centimeters and 1 mile over 5,280 feet. Okay, and I can always flip-flop them too, so 4 different ways to really write that. Now, the inch and the centimeter, that is going to help me go from inches and feet, which are more American units, imperial units, we call them, to centimeters, which are more metric system units. So, you might have to make a jump from, metric to the English version. Let's do this example. The Empire State Building is approximately 381 meters high. How many miles high is the Empire State Building? So 381 meters. All right. So my known and my unknown. Now I have to come up with a plan of attack. So I know I need to get from meters to miles. I don't have a direct conversion to that. And meters is metric. Miles is English. So I'm going to have to essentially try to get to that inch equals 2.54 centimeters so I can convert to the correct units. Okay. So what that means is I'm going to go from meters to centimeters. So I would definitely write this down as your plan of attack. Again, meters to centimeters. I need to get to, miles, which means I need to get to feet, which means I need to get to inches. I can only do that if I get to centimeters first. I can't get to inches from meters. So I'm going to go from meters to centimeters, centimeters to inches, inches to feet, and feet to miles. So one little trick here, every one of these arrows that you drew essentially is going to be a multiplication in your work, as you do it, as you multiply across. So I start off the same. What am I given? 381 meters. Oh, those are just the conversions underneath there. 381 meters is what I'm given over 1 or over x times. Okay. So if I have meters on the top, I know I need meters on the bottom to cancel. And my plan of attack tells me I'm going to centimeters. So how many centimeters in a meter? That's 100. Meters cancel. Then I'm at centimeters. So I need to go from centimeters to inches. I just learned this conversion factor. It's centimeters on the bottom, and that's the 2.54 that goes with that. So that one's right here. Okay. So the 2.54 always stays with the centimeters. The 1 always stays with the inch. Again, 1 always goes with the one that's bigger. 1 is bigger in this case. Or the inch is bigger, I meant. So 1 inch is equal to 2.54 centimeters. Centimeters cancel. Then I have the inches I need to get out of. So inches to feet, right? So inch on the top means inch on the bottom. In that case, 12 inches and 1 foot. Inches cancel. And then finally, feet to miles. So feet goes on the bottom, 5,280, and mile on the top. So now this one is not quite as simple. Let me see if I have this. Okay. So you do have to be careful with your calculations here. So what I would do is multiply all your numbers on the top. So I have 381 times 100. All right, so that should give you 38,100. And then you're going to divide that by the numbers that you get on the bottom. So you need to multiply all those numbers on the bottom. So I have my calculator here, 2.54 times 12 times 5,280. And I get 169.34.4. Okay. So now when I take my calculation here, I have 38,100 divided by 169.34.4. And this is what I get. Okay. So now I need to figure out, okay, where am I rounding to, right? My numbers starts with 3 sig figs, 381. So that means I need to round to my third significant figure, which is the 6. So 236, but since that's a 7, that means that is going to bump up to a 7. So 0.237 miles. That's a little under a quarter of a mile. All right. So here is what I want you to work on for the rest of the day today. And you can either take a picture of this or the teacher can leave this up on the screen here for you so you know what you need to be working on. So number 1 was the video that you're watching now. So check your answers to worksheet number 3, and then we did the notes on page 25. So that is done. Now what I want you to do is work on worksheet number 4 that extends from pages 26 to 27. Just use dimensional analysis, use DA, use exactly what we've been doing, these practice problems here. In addition to that, I want you to do Bellworks number 3 and 4. There's 2 of them on page 3 that all have to do with what we've been talking about. Page 3 and 4, or sorry, Bellworks 3 and 4 on page 3. And then finally, your exit ticket number 2. So either take a picture of this and make sure that you do all these, or like I said, it can be left up as well. All right, I will stop my recording here.